Using R in statistics. This video presents our experience in using R in our introductory statistics course. Our experience with R showed us the following. R does not have a steep learning curve. It has not been a serious challenge for the students to learn the R functions needed in the course. Students need to learn only a small number of R functions, about 10 functions, to generate the outputs needed in the course. R functions are relatively easy and very intuitive. R codes are very efficient to obtain the outputs for data analysis. These points will be presented on the following slides. Data and R functions needed in the course. R functions needed in the course are presented based on this data. The data set has 70 observations and 5 variables. All the calculations are on the house values variable. These are mainly the subjects covered in the courses. The second column lists all the R functions to generate outputs needed for these subjects. As listed, there are about 10 R functions that the students need to analyze the data in the course. R functions relatively simple and very intuitive. For example, for the numerical measures, mean, median, and SD, standard deviation functions are used. For visual displays, histogram and box plot functions are used. To calculate the cumulative probability for a normal distribution, the p-norm function is used. For a two-sided hypothesis testing problem with mean is equal to 200, the t-test function is used. For correlation, COR, correlation function is used. For a simple linear regression, LM, linear model function is used. The functions for other subjects are similarly intuitive. Detailed information in the use of these functions is provided on the poster PowerPoint slides. It is very efficient to write R functions. To obtain a multiple regression using the data as given in the table, no pre-processing of the data in this table is needed. A simple short statement, LM, within parentheses, to predict value by using area plus basement and location is needed to obtain the regression output. Suppose we want to obtain the same multiple regression output by using Microsoft Excel. Significant pre-processing of the data is needed on the last 3 columns. First, the categorical variable basement is to be expressed by numerical dummy variables with 0 and 1. Using the if function, these yes and no values will be expressed with 0 and 1 as follows. Second, the categorical variable location, which has 3 levels, A, B, and C, is also to be expressed by numerical dummy variables with 0 and 1. Using the if functions, these A, B, and C values will be expressed as 0 and 1 in 2 separate columns as follows. Third, the variable SS is not included in the regression model. Therefore, it needs to be moved to the last column or to be deleted to show it as follows. After completing the pre-processing, the final table will be as shown on the right. Using this table, the regression model will be obtained by selecting data, data analysis, regression, select Y range, select X range, select labels, and click OK. All these operations are not trivial. Remember that For all these in R, this short and simple LM function is needed to obtain the regression output. Note the following as the final remarks. Using R has been well received by the students. In their teacher course evaluations, the students did not have any serious complaints about using R in the course. As stated earlier, students need to learn only a small number of R functions. But the instructors need to know much more than these 10 functions. The purpose of this presentation is not to suggest that R be the software to be used in the courses. Rather, it is to share our experience and provide information to those instructors considering to use R in their statistics courses. See the poster PowerPoint slides for more detailed information.